this lecture will be on atomic structure. So basically looking at what is inside of an atom. There are three parts that are inside of an atom, three different particles. There are protons, neutrons, and electrons. And what I want to show you first are the symbols for these and the charges and where they are located. So protons have a positive charge. So when we write the symbol for a proton, we write it as P positive. And protons are found in the nucleus. And I believe I spelled that wrong. I sure did. They are in the nucleus of an atom. And the nucleus is similar to the nucleus of a cell, where it's sort of the center, it's the brain or the most important part. So protons are positively charged, we write it as P positive, and they are found in the nucleus. Neutrons have no charge, or we say that they are neutral. Their abbreviation is just a lowercase n, and they are also found in the nucleus. Electrons have a negative charge. We write their abbreviation as a lowercase e with a little negative out of it, after it, and they are found in what is called the electron cloud, which surrounds the nucleus. So those are the three parts, their symbols, and where they are located. So moving along, let's talk about how to draw atoms. This is a two-dimensional drawing of a three-dimensional thing, but what I really want to show you is how you would represent where those protons, neutrons, and electrons are. So for carbon, this is the first one that we'll start with. Carbon has 6 protons, 6 neutrons, and 6 electrons. So we just draw a circle. This circle represents the nucleus. Inside of it we put 6 protons and 6 neutrons. Now, the electrons are going to be outside of the nucleus, and they are found in different levels, sometimes called energy levels. So the first energy level, just draw another circle, the first energy level can only hold 2 electrons. So we'll put a little circle here with an E negative, and a little circle here with an E negative. So there are 2 of the 6 electrons represented. So now the next energy level can hold 8 electrons. Now we don't have 8 more electrons. We've already represented 2 of our electrons. Here's 1, and here's the second one. So we have 6 to deal with, 6 to place. So of our 6, we've already placed 2, so we have 4 left. So 1, 2, 3, 4, and each one of these represents an electron. And so that would be a basic rendering of carbon. So now let's repeat this process with phosphorus. So in the nucleus, you are going to have both the protons and the neutrons. So 15 protons and 16 neutrons. We'll then draw our first energy level, which can only hold 2 electrons. So there are 2 electrons. And now our second energy level can hold 8. So we'll say 1, 2, 3, 4, 5, 6, 7, 8. So now we have 10 electrons drawn. So we have 15 electrons that we have to place. So we need 1 more energy level. And we are going to put 5. 1, 2, 3, 4, 5. So 2 electrons can go in the first, 8 electrons can go in the second, and 18 electrons can actually fit in the third. So I'm going to draw lithium up here. So here's our lithium nucleus, 3 protons and 4 neutrons. In our first energy level, there is 2 electrons. And then our second energy level will only have 1 electron. So there are the 3 protons, 4 neutrons, and the 3 electrons represented. Now we need to start talking a little bit about the periodic table. There are different numbers and symbols on the periodic table, and so I wanted to show you what those numbers and symbols actually represent. So if we go here, here is a large version of one of the blocks, and this block is representing oxygen. So on every periodic table, you're going to have these 4 things that are really important. One is the name of the element. So here's the name of the element. You are also going to have the symbol for the element. Now symbols are either 1 letter or 2 letters. This one is just 1 letter. If it's 1 letter, that 1 letter is capitalized. If it's 2 letters, like sodium, the abbreviation for sodium or the symbol for sodium is Na, the first letter is capitalized and the second letter is not. So this would be sodium symbol. We then have a number that is up here in the corner, and this is called the atomic number. This number is like the social security number for the element. So oxygen is always number 8. Its atomic number is 8. The atomic number tells you the number of protons in that atom. So oxygen always has 8 protons. The last number down here is called the mass number. The mass number tells you the mass of one atom of that element. So the mass number tells you the mass of one atom of oxygen in this case. And to figure out the mass number is equal to the number of protons plus the number of neutrons. So mass number equals protons plus neutrons. So here are some of those definitions. Atomic number equal to the number of protons. Now, the number of protons is going to be the same as the number of electrons if we're talking about a single atom. So this is before that atom has joined with something else, like hydrogen and oxygen joined together to make water. So this would be just for a single atom. So the atomic number is going to tell you the number of protons, and that number is going to be equal to the number of electrons for all of the atoms that we are talking about. Mass number is the total number of protons and neutrons. So you have to add protons and neutrons. Now finally, let's practice using those just a little bit. So if we look at this chart, we have atomic number right here. Now remember, atomic number is going to be equal to the number of protons and equal to the number of electrons. So if we look here at iron, iron's atomic number is 26. That means it has 26 protons and 26 electrons. Now, to figure out the number of neutrons, we have to look at the mass number. So, mass number, remember, is equal to protons and neutrons. So, we have 56 is our mass number for iron. So if we said 56 and we take away the number of protons, that's going to tell us the number of neutrons, because mass number is protons plus neutrons. So neutrons would equal mass number minus the number of protons. So let's look at mercury. Well, we see here that mercury has 80 electrons. Well, that means that it's going to have 80 protons, and its atomic number is going to be 80, because these three will always be equal. It has 120 neutrons, so neutrons plus protons is going to tell us our mass number. So our mass number is 200. Let's look at our last example, radon. So radon has 86 protons. That means its atomic number is 86. And it has 86 electrons, because these three are always going to be equal. Its number of neutrons is 136, so neutrons plus protons is going to be 222.